Where are we, Seatail?
This is my secret lab. Here, you'll find all of my projects.
P equals NP. Wow, great job, puny mortal. Too bad it makes obfuscation harder, though. Ugh.
Oh, that. I did that in an afternoon. I needed that to develop this awesome thing.
A fancy cardboard box?
Not just any cardboard box. Here, let me power it on.
What the? Where the hell am I?
You're in some basement in a city somewhere. That sounded bad, but I promise you it's not as bad as you think it is.
I feel like I've seen that kid before, though.
Well, I'm the one and only Master Junior Trooper. Now I'm gonna pummel you, dumb lizard!
It worked!
What worked?
I managed to transport a living entity through dimensions! Not a particularly friendly entity, but hey, it works!
Hey, you should call that the box port. It has a nice ring to it, you know? NDBall is an esoteric programming language that was created by Aspwell. At first glance, it kinda feels like beefunge. There is a ball, and it moves along the program space, running commands in the process. Unlike beefunge, however, NDBall is confined to only 5 cells per dimension. Wait a sec, that's stupidly limiting! How are you supposed to write any useful programs using just 25 squares? Just a sec, Idex. Where did I say it only had 2 dimensions? You didn't say that. It just seemed natural. Idex, this is an SOLang. You should know it won't be natural. NDBall's ball can move in, well, n dimensions, meaning it can move into the 3rd, 4th, 5th, or however many dimensions you want. So, how do I visualize this? You don't! But let's start off simple with a one-dimensional program that prints a single number. An NDBall command starts with its coordinate in n-dimensional space, followed by the command itself. The ball starts at the origin, so the first thing it will run will always be at position 0. We can move along dimension 0 by writing less than 0, or right 0. This will move the ball forward in the 0th dimension, which we can visualize as this line. The ball also holds a value, and at cell 1, we can increment that value by 1 using the plus sign. The ball can also be decremented using a minus. Up next in cell 2 is a conditional statement, specified by the command y. The first argument is a numerical value. If the ball is less than this value, it will run the second argument, which will be going backwards in the 0th dimension. Otherwise, it will run the third argument, going forwards in the 0th dimension. When this happens, the ball will have the value 5. Now, we can print it using p. Now, when we run this program, the ball will increment itself bouncing over the plus until it reaches 5, and when it does, it prints it out. Grr! After it prints, the ball shatters! Fix it now! Oh yeah, the dimensions are only 5 cells long, so to stop the ball before it crashes into the wall and shatters into a billion pieces, we need to put in an ending. So now it works perfectly. Moving up to 2 dimensions, we have the truth machine. This simple program takes an input as either a 1 or a 0. 1 will cause the truth machine to print 1 indefinitely, while a 0 will cause it to print a single 0 and stop. Because when you lie, everything stops. The ball starts by moving forward in dimension 0. Then, in cell 1, it takes an input from the user as a number, represented as the % symbol. Then, it goes into a conditional statement. If the input is less than 1, it continues on dimension 0, where it prints the ball's value and exits the program, similar to the previous program. Otherwise, it moves forward in dimension 1. Oh, look at that! We have a y-axis now. This prints the input, which is a 1, and then it moves back into the conditional, where it will just start moving upwards again, creating a loop.
There will be no escape.
So, what if I want to store data somewhere that isn't the ball? Well, in this next program, I'll show you some. This program will count up from 1 infinitely with new lines between each number. One place data can be stored is the apioform hive. Apioform? What's an apioform? But anyway, have this apioform. Anyway, when the ball hits the A command, an apioform goes into the hive. The F command, meanwhile, causes an apioform to leave the hive.
I'm gonna kill you, stupid beeoid!
No, don't! If you do that, it will disrupt pollination and you will kill us all! I'm just gonna go pollinate flowers. It won't sting you unless you try to kill it, you idiot. Anyway, first things first, this program will add 10 apioforms to the hive.
Grr, why 10? I hate the number 10 as much as I hate apioforms! Which is a lot, by the way.
Go away, you weirdo. 10 is used because 10 is the ASCII code for the new line. That means that we're storing the character for the new line in the apioform hive. Anyway, after the 10 apioforms are added into the hive using this loop, the program enters the third dimension. This is going to get hard to visualize, so I hope the version of me that's animating this has come up with a solution by then. The ball will then run into an octothorpe, which acts differently depending on how the ball is moving. What's always true though is the octothorpe stores an integer. If the ball is moving in the same direction as specified here, the octothorpe is written to. Otherwise, the ball's value is replaced with the value held by the octothorpe.
Hold on, you never gave it a value though.
Correct, so it starts at 0. Next, the program adds 1 to the ball and prints the ball's value out. It then goes into the octothorpe from the same direction, setting its value. Finally, the hive's value is printed by setting the ball's value to the value of the hive and printing out the value of the hive as an ASCII character, using the lowercase p. Finally, it loops back to the octothorpe, creating the loop. Anyway, these programs were quite simple, but that's because it takes a lot of dimensions in order to make an NDBall program do even basic tasks. The Hello World program, for example, runs in 20 dimensions. I don't even know how to think about that. Aspwell also wrote a program that adds 2 numbers together. Apparently it took him 4 hours to write it, and it uses 9 dimensions. Anyway, thanks for watching, and I'll see you next time!
We are the strangers to love. You know the rules, and so do I. A full commit